There is a car on sale right now that does not have a battery hidden under the floor. The battery is the floor. It is also part of the walls. It is part of the metal frame holding the whole car together. And here is the part that sounds made up. You pull up to a charger, wait about as long as it takes to grab a coffee and check your phone, and drive away with over 600 miles of range. This is not a prototype sitting behind glass at a car show. It is parked in driveways and showrooms right now. And the strangest part of this whole story is that the company that built it never planned to make cars at all. They started by making tiny batteries for cell phones in a single rented room. To understand how a phone battery company ended up building one of the fastest charging cars on Earth, we have to go back to where this all began. From a tiny room to a car revolution. In 1995, a man named Wang Chuanfu rented a small space in Shenzhen, China, and started a company with about 20 workers. Their job was simple: build rechargeable batteries for mobile phones. At the time, cell phones were exploding in popularity all over the world, and somebody had to make the tiny power packs that lived inside them. Wang saw that need and jumped on it with everything he had. This was not a glamorous start. There was no factory full of robots. There was no big office tower with a fancy logo out front. Just a small team, a lot of hand assembly, and a deep obsession with one single question. How do you make a battery that works well, lasts a long time, and costs less than everyone else's battery? That question sounds simple, but answering it takes years of trial and error. You have to test what happens when a battery gets too hot. You have to test what happens when it gets dropped, squeezed, or used over and over again until it wears out. Year after year, that company, called BYD, got better and better at answering that question. They studied every part of a battery cell, down to the smallest details most people never think about. What makes it strong? What makes it fail? What makes it dangerous if something goes wrong? While other companies were busy building cars and just buying whatever battery was cheapest at the time, BYD was busy becoming one of the few companies on Earth that truly understood how a battery behaves under pressure. That knowledge did not just sit on a shelf somewhere. It became the foundation of everything they would build next. In the early 2000s, BYD made a move that surprised a lot of people in the business world. They bought a struggling car company and decided to start building cars themselves. People close to the industry thought this sounded strange. Why would a battery maker, a company with no real history of building vehicles, suddenly try to compete with car makers that had been around for decades? But BYD did not think like a normal car company, and that difference turned out to matter more than anyone realized. A regular car company usually builds the shape of a car first, figures out how everything fits together, and then goes shopping for a battery supplier to fill in the gap. BYD did the opposite. They started with the battery, the one part of the car they understood better than almost anyone on the planet, and built everything else around it. The battery was not just a part they bought, it was the starting point for every decision that came after. That mindset would matter more than anyone realized at the time. Because 2 decades later, it would lead to a piece of technology that made the entire global car industry stop and pay attention all at once. If a story like this gets you curious about how things actually work behind the scenes, this channel is built for exactly that. We dig into the real history behind big tech moments, not just the headline. Subscribe now, because in the next few minutes we are going to walk through the exact moment BYD shocked the world, and you will want to see how all the pieces connect. Let's keep going, because the real turning point did not happen in that first rented room. It happened years later, with a battery shaped like nothing anyone had tried before. The hidden problems every electric car owner knows. Before we get to the breakthrough, you need to understand the problems electric cars have been quietly living with for years. These are the things that do not always show up in the shiny commercials. Start with charging time. Car ads love to say, fast charging. But for most electric cars on the road today, a real fast charging stop takes around 30 to 40 minutes to get a useful amount of power back. That does not sound like much until you actually live it. 30 minutes is not a quick stop. It is a full meal. It is a long phone call. It is half a movie. For someone used to spending 5 minutes at a gas pump, that wait feels like a real change in how you plan your day. It adds a whole extra layer of planning that a gas-powered car simply does not need. You start picking restaurants based on whether they happen to be near a charger. You start timing road trips around where the next station is, instead of just driving until you feel like stopping. Then, there is range. Most affordable electric cars today travel somewhere between 250 and 300 miles on a full charge, and that number assumes everything is working in your favor. Mild weather, steady highway speeds, no extra strain on the system. Take that same car into a real winter, and the range can drop by 30% or more. Cold weather slows down the chemistry inside a battery, so the car has to burn extra energy just to keep the battery warm enough to work properly in the first place. It is a bit like trying to run a race right after waking up from a deep sleep. Your body works, but it needs extra effort just to get moving. Cold weather hits charging speed too, not just range. Some drivers have pulled up to a fast charger in January and watched it deliver power at half the speed it managed back in August. They sit there for 20 or 30 extra minutes, watching the battery percentage crawl upward while the temperature outside keeps dropping around them. But here is the part that almost never makes it into the ads. In nearly every electric vehicle sold today, the battery is one big, heavy box bolted underneath the floor of the car. It does one job and one job only. It stores energy. It does not help hold the car together. It does not make the car stronger in a crash. It just sits there, dead weight from a structural point of view, while engineers have to design the entire rest of the car around it. Think about that for a second. The battery goes in first, like a piece of furniture that cannot be moved, and then the rest of the car gets built around that fixed shape. This creates a frustrating cycle that keeps working against itself. The battery box adds weight. Extra weight means the car needs more energy just to move itself down the road. More energy needed means you need an even bigger battery to get the same range as before. And a bigger battery weighs even more than the last one. Around and around it goes, like a dog chasing its own tail. Every single electric car company on the planet has been wrestling with this same basic problem. Charging that takes too long, range that shrinks the moment winter shows up, and a battery that is just dead weight sitting under the floor instead of doing something useful for the car. BYD looked at this whole list of problems and decided that small fixes were not going to cut it. You cannot solve a problem this deep by tweaking the edges of it. They needed to rethink the entire idea of where a battery belongs inside a car, starting from a totally blank page. And the question that started it all sounds almost too simple to be the answer. What if the battery was not just a part you bolt onto the car? What if the battery became the car itself? When the battery becomes the car. To get to that question, BYD first had to solve a smaller problem. They needed a battery cell shaped in a way nobody else was using. Most electric car batteries use chemistry that packs in a lot of energy, but can be risky if it gets damaged or overheated. Around 2020, BYD made a bet that seemed backward to a lot of the industry. They chose a type of battery chemistry called LFP, which most competitors had been quietly moving away from because it could not store quite as much energy per pound as newer options. It was seen as the cheap, weaker choice, the kind of battery you settled for if you could not afford anything better. BYD saw something different. They saw a chemistry that ran cooler, lasted longer, and almost never caught fire, even when badly damaged. So, instead of giving up on it because of its weaker energy storage, they redesigned the cell from the ground up. They made each cell long, thin, and flat, like a blade, and packed them tightly side by side with no wasted space in between. No bulky plastic boxes around groups of cells, no extra padding stealing space that could be used for actual energy storage. just clean, dense rows of battery laid out as efficiently as possible. Then they proved how tough this new design was in a pretty dramatic way. BYD drove a fully loaded 46-ton truck, heavier than most loaded freight trucks on the highway, straight over one of these battery packs. The pack did not catch fire. It did not leak. It barely even dented. In a separate, equally brutal test, engineers drove a steel nail straight through a fully charged cell, the kind of test specifically designed to trigger a fire in a normal battery by causing a short circuit on the inside. Older battery types can shoot past 900 degrees Fahrenheit and burst into flames during that exact test. BYD's blade cell stayed under 140 degrees, with no smoke and no fire at all. That toughness mattered more than it might seem, because it set the stage for the real leap forward. If a battery pack could survive a 46-ton truck without a scratch, maybe it did not need a separate protective box wrapped around it at all. Maybe the battery itself was already strong enough to become part of the car's skeleton. That is exactly what BYD built next, a system they call cell-to-body. Instead of placing a finished battery box underneath a separate car floor, the top surface of the battery pack becomes the actual floor of the cabin. You are not sitting on top of a battery anymore, with a layer of metal and plastic in between you and the cells. You are sitting on the battery itself. The cells spread out and carry weight and force across the frame, the same way steel beams hold up the walls and roof of a building. Here is a simple way to picture it. The old design is like strapping a heavy backpack to the belly of the car. It comes along for the ride, adds weight, and the car has to work around it without getting any real benefit in return. The new design is more like your own skeleton. Your bones are not just sitting inside you doing nothing while your muscles do all the work. They hold you up. They absorb impact when you fall, and they make every single movement possible in the first place. BYD made the battery do that exact same job for the car, instead of letting it just sit there as extra weight. The results were hard to ignore once the engineers ran the numbers. The new design made the body about 70% stiffer when twisted, a level of strength normally found only in luxury cars that cost 2 or 3 times as much money. By removing the separate casing around the battery, more of the available space inside that area could be filled with actual energy-storing cells instead of packaging, wiring, and protective layers, with BYD reporting that around 2/3 of the system's total volume is now active battery material. That means more energy fits into the exact same physical footprint without making the car any heavier than it needs to be. Less wasted weight also means the car uses its energy more efficiently, which stretches the range even further on the exact same size battery. And because the battery is now woven directly into the structure instead of just sitting inside it, the whole car handles better too. There is less vibration, less body roll in corners, and a more solid, planted feeling at highway speed, the kind of feeling you usually only get in much more expensive cars. All of that is genuinely impressive on its own, and most car companies would happily stop there and call it a win. But none of it is the number that made the entire global car industry go quiet at once. That part is still ahead, and it might be the single most unbelievable detail in this whole story. The 5-minute charge that shocked the world. In March of 2025, BYD held an event where they walked the public through the engineering behind a new charging system. The crowd was paying attention, watching closely, but nobody seemed especially shocked yet. Engineers had been promising faster charging for years, so a little skepticism in the room made sense. Then a number went up on the screen, 10% to 70% in 5 minutes. 5 minutes. Using a charging station capable of delivering up to 1,000 kilowatts of power, roughly 40 times more powerful than a typical home charger you might plug into overnight, BYD said its new platform could add about 250 miles of range in the time it takes most people to use the restroom and grab a snack from a vending machine. That was already a record-breaking number for a production car, and it landed first in 2 of their sedans, the Han L and the Tang L. both of which went on sale to regular buyers within weeks. Then, exactly 1 year later, in March of 2026, BYD topped themselves again. They unveiled a second-generation version of their Blade battery, paired with an even more powerful charger capable of 1,500 kilowatts. The new claim was almost hard to say out loud without doubting it. 10% to 70% charge in 5 minutes. 10% to 97% in just 9 minutes. BYD even gave it a catchy little phrase to sum it up. Ready in 5. Full in 9. Let that sit for a second. 9 minutes to go from nearly empty to almost completely full. That is shorter than most people spend scrolling their phone after waking up in the morning before they have even gotten out of bed. It is shorter than waiting in line at a busy coffee shop on a Monday. Now here is where it gets even more interesting, because cold weather has always been the quiet killer of electric car excitement. Every winter, stories pop up online of EV owners stuck at a charger for far longer than expected, watching their battery creep up at a fraction of the normal speed. To prove their new battery could handle the worst of it, BYD took one of their cars, a Denza Z9 GT, and left it sitting outside for a full 24 hours in a freezing room set to negative 30 degrees Celsius, or about negative 22 degrees Fahrenheit. That is the kind of cold where a metal door handle can snap right off if you tug it the wrong way, and where most batteries practically shut down without serious help. Then they plugged it in front of cameras, with no edits hiding what happened next. The battery climbed from 20% to 97% in just 12 minutes. That is only about 3 minutes slower than the exact same charge at a comfortable room temperature. BYD even built a little slogan around the whole demonstration. Ready in 5. Full in 9. Cold add 3. 3 extra minutes. In the worst cold most drivers will ever experience in their entire lives. That kind of cold weather performance has historically been one of the biggest weaknesses for this particular type of battery chemistry, which makes the result even more surprising to people who follow this industry closely. Normally, freezing temperatures force a charger to slow way down on purpose, because a cold battery resists the flow of electricity the same way thick, cold honey resists being poured. BYD solved this by building careful temperature control directly into the structure of the battery itself, gently warming the cells just enough to accept power quickly, even when the world outside is brutally cold and unforgiving. The car carrying this technology to its highest level right now is the Yangwang U7, BYD's flagship luxury sedan. With its largest battery option, it is rated for over 1,000 kilometers of range on a single charge, which works out to about 625 miles under Chinese testing standards. Real-world driving will likely bring that number down somewhat, the same way it does for every single car on every test cycle in every country. But even with that honest adjustment in mind, the range is remarkable for any vehicle on the market today, let alone one that can also charge this fast. A car this fast at charging is only useful if there is somewhere to actually plug it in at that speed, though. And it turns out, BYD had already been quietly solving that problem for years, before most drivers ever heard the words flash charging for the first time. Why this changes everything for you. A charger capable of delivering 1,500 kilowatts is not something you can just plug into a regular power line. That much electricity, pulled straight from the grid all at once, at thousands of charging stations across a country, would put enormous stress on the entire power system. This has always been one of the biggest practical roadblocks standing between superfast charging and everyday use. BYD's answer is almost surprisingly simple. Each flash charging station has its own large battery built right inside it. The station pulls power slowly and steadily from the grid throughout the day, storing it up bit by bit. Then, when your car pulls in and plugs in, the station releases all that stored energy in one fast burst, without ever spiking the demand on the local power grid. Picture it like filling a water tower little by little all day long, and then opening the tap all the way for the person who shows up needing water right now. The pressure is already there because the work was done ahead of time. BYD had already built over 4,000 of these stations across China before the new charger technology even reached the public, and that number has since grown past 5,000, spread across nearly 300 cities. Their goal is 20,000 stations across China by the end of 2026. That is not a hopeful slide in a slideshow. That is infrastructure being poured into the ground while engineers were still finishing the technology that would use it. And in 2026, BYD started bringing this same charging network to Europe, with plans for thousands more stations there within the next year. The scale of BYD as a company is what turns this from an impressive announcement into something with real staying power. In 2025, BYD sold over 4.5 million vehicles worldwide, everything from small, affordable city cars to high-performance luxury models, and for the first time ever, BYD sold more fully electric cars than Tesla, becoming the world's top-selling electric car brand. Their vehicles are now sold in well over 100 countries. And the technology behind all of this, the structural battery design and the lightning-fast charging, is not locked away in one expensive flagship model. It is a platform built to spread across BYD's entire lineup, from budget-friendly cars all the way up to luxury sedans, and even into trucks and buses down the road. Every other car company building electric vehicles right now is studying what BYD has done and figuring out how far they need to move to catch up. Some have their own versions of structural batteries in the works. But the full combination BYD has put together, a battery that is also the car's skeleton, a charge that takes minutes instead of hours, cold weather performance that barely slows down, and a charging network already being built at scale, is something nobody else has matched yet in a car you can actually walk into a dealership and buy. The three biggest reasons people have hesitated to switch to electric cars have always been the same. Charging takes too long, the range is not enough, and cold weather makes everything worse. What BYD has built goes after all three problems at the exact same time, and right now, with a battery that holds the car together, that argument is getting a lot harder to make. A company that started out making tiny batteries for cell phones in one small rented room just helped redefine what an electric car even is. Not by building a bigger battery, by making the battery the car itself. If this story surprised you, do me a favor and hit that like button before you go. Subscribe and turn on notifications so you catch the next one as soon as it drops, because we cover stories like this right when they are happening, not months later. And I want to know what you actually think. If a 5-minute charger showed up near your home tomorrow, would that finally be enough to convince you to go electric? Drop your honest answer in the comments. I read every single one.